Hello, Rochelle here. I thought I'd let you see what I look like for a second before starting this video. So in this video, we are going to be talking about factoring polynomials that are in a special form. If you recall, this is the standard form for a polynomial, and this right here is the factored form for a polynomial. What you see highlighted is what I would call the only special form that we really want to look at. In textbooks and online, you will see forms like this where you have something that is squared, and they'll tell you that that's equal to, wow, that's not right, x squared plus 2ax plus a squared. And they'll have you look for this form. I don't think that that is helpful. So I don't expect you to memorize those, because if anything has three terms like this, you're either going to guess and check or you're going to use the AC method. So in terms of this one, this means that if we have anything squared minus anything squared, the form is going to look like this. So an example is if we have x squared minus 16. If you'll notice, this is x squared and this is 4 squared. So what that's going to factor into is x plus 4 and x minus 4. It doesn't matter which order you write that in. And the reason that this works, remember we can always check our work, is we're going to multiply the first together, then the outside, then the inside, then the last two. The middle terms, because there's a minus and a plus, end up being 0, and we're just left with our original here. So one thing to note is that a squared plus b squared is prime. What that means when I say it's prime, it's not factorable. The only thing you can factor with two terms that are being added is if you can factor out a greatest common factor. So let's go ahead and look at some more examples. So in this case, this looks a lot more complicated. I have highlighted over here perfect squares so that you might, maybe try and commit some of these guys over here to memory. I hate how that goes dark before it goes light. Anyway, so like I look here and I see 49 and I see 81. I already knew that this was 7 squared and this was 9 squared, but in case you don't know those, these are some good numbers that you might want to try and think about, memorize. So what this means is, now we have two different variables, but that doesn't mean anything changes. So we want to think, what has been squared here? Well, we know the 7 has been squared. And if I look at it, the y has been squared. And I know that 7y times 7y will give me this 7y squared. If I look here, I know that then if I square 9, I'll get 81. And if I square t, I'll get t squared. And I know that 9t times 9t equals 81t squared. Now, it doesn't matter where if you put the negative first or second, that is still your factors. Those are still your factors. And remember, you can always check your work by multiplying out. So here was an example from a previous video I did. So in this case, if you remember, the first step in all of them is to factor out the greatest common factor. I didn't on these ones because I knew that there was nothing in common, but I probably should have mentioned that. Here, I see that they definitely have a w in common, and I think 3 can go into both of them. So if I divide this by 3w, or I ask myself 3w times what is going to give me 12w cubed, I know that 4 times 3 will be 12, and I know that w times w squared will be w cubed. Now if I divide by 3w here, I know I'm going to have a minus, and that's going to be 9. And now if I look at that, I don't want to stop there. I notice that this is a subtraction, and I notice that these numbers are perfect squares. So what that means is I am going to be able to write this as a difference of perfect squares. I know that 2 squared equals 4. And I know that if I square w, I'm going to get w squared. And I know that 3 times 3 is 9. Now, a lot of times people start boxing this in and they forget to bring their 3w down, but it is important to bring that down. Now, if I wanted to check my work here, I would want to multiply these together first. I want to multiply this together first. And then I want to distribute the 3w second. So now that we've gone over all types of factoring, we want to come up with a strategy. How are we going to attack problems? Now, everyone's strategy can be a little bit different, but I think I'm going to go over what I would do, and you can see what works for you. I think the first thing that we want to notice is we want to notice the number of terms in the polynomial. If there are, and I'm just going to put this one up here, if there are 4 terms, and that might look like, x squared plus 3x minus 4x minus 12, something like that, then I want to do factor by grouping. If there are 2 terms, then I'm going to see, is it, actually, how would I do this? Is this difference? Or is it a sum? If it's a sum, it's not factorable. And if it's a difference, if it looks anything like this, I know that it's going to factor into this form. So here I replaced the letters with just shapes. Now, I did not mention the very first thing we should do, no matter what. The first step when we are factoring is always, before we even look at the number of terms or anything, is to factor out the greatest common factor. So things could be factorable in that we could get the greatest common factor out, but then we can't do anything after that. We would still call that factorable. It just has an endpoint. Most of our factoring has 3 terms. And I kind of have the same strategy whether A is equal to 1 or A is not equal to 1. But sometimes people do different things. But for me, I do the same thing no matter what. And that is, what I do is I try guessing and checking. For me, I would put in the number that you feel comfortable with, but I'm probably not going to spend more than 20 seconds guessing and checking, honestly. Maybe a minute would be my limit. But if that doesn't work, then what I'm going to do, this is what I try first. So this would be my second step because up here's my first step. Then my third step is just going to be to use the AC method. Okay. So first step, factor out the GCF. Second step, I guess I could call the second step is identifying the number of turns. So I'll change this into a 3 and a 4. So the second step is, are there 2 terms? Are there 3 terms? Are there 4 terms? If there are 2 terms, or 4 terms, I'm going to factor by grouping. If there are 2 terms, I'm either going to have a difference or not be able to do anything more. If there are 3 terms, sometimes I look at whether A is equal to 1 or A is not equal to 1. Because if A is equal to 1, I will guess and check. Sometimes if A is not equal to 1, I will go straight down to the AC method. Because if I'm looking at it and those numbers are too big, I'm just going to go straight there. So in my next video, we'll figure out how we can practice using this strategy.